Okay, welcome back. We're on page 278 talking about removable drives, and in a server environment that's pretty dumb. For example, I had a scenario where they actually put tape over the USB drives in the server room, so no traveling salesman would come in there and plug something into it. Remember, we even had a GPO that would remove the USB storage device driver so that you could plug things in. So servers are not a place where you expect to find USB ports. Maybe one on the front panel, but probably none in the back. Graphics cards. So unless you're doing crypto mining or super duper AI stuff, or you're doing a render farm for graphics, you probably don't need a very sophisticated graphics card. Most servers come with integrated graphics on the CPU, and that's good enough because all you need to be able to drive a display adapter. That's it. They don't need to do anything else. So that whole concept, now obviously you can get these what's called a headless graphics card. It's strictly for doing neural processing or multiple language kind of scenarios. All the cool stuff that we keep talking about with AI. Or you're a render farm, or you're a crypto miner, or you're using the graphics card but not for graphics. So you don't even need to have a monitor plugged into it. It's a headless guy. So specialized cards that are graphics cards, you buy them from NVIDIA and AMD and all the rest of the folks. They just specialize. They're very expensive, and they're tuned just for doing the kind of work you're talking about. So I probably don't need anything more than what's on the chip, or maybe a discrete graphics card. But again, servers are typically not like a full height guy. Not like you can go, so the cards are kind of turned sideways, so they're physically would fit. But you can't buy a monstrous. How if you were to get a NVIDIA 5090, its thickness is huge, right? It's thick. It probably wouldn't even fit into a server, and if it did fit into the server, it wouldn't have sufficient airspace to cool down. Servers are rather compact. They're probably in a U2 or U3 or U4 rack unit mount. No, they're not very thick. The servers aren't very thick in size. So installing a super duper high-end graphics card is a recipe for disaster, and he doesn't have enough room, doesn't have enough airflow. Okay. So just a software-only version of a network card a graphics card is probably fine unless you're doing one of the other things. Cooling, page 280. So everything generates lots of heat. I mean, these EPYC guys and the Xeon guys are rather power hungry. Again, we're not talking about, at home, there's a practical limit when you plug it into a standard 15 amp electrical socket in your house. Most people have a 15 amp, and you can do the math, say, okay, 15 amps of 120 volts, blah, 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 blah. Have you ever wondered why you don't have 3,000 watt hair dryers? Because 3,000 watts would blow the fuse. So there's a practical limit on the number of watts you can get out of a 15 amp circuit, particularly if you have something else plugged into it. And we're talking about the circuit going to the room, right? Your study, my study. Okay, I can't have like 3 2,000 watt power supplies running off of the same circuit. I'll pop the breaker. Okay, so again, in the server world, they're probably not 20. They're probably 240 volt. With a 30 amp breaker on it, and there's multiple ones in there. So the power cords all plug in. They have redundant power supplies. If one power supply fails, it'll continue to run. All that kind of good stuff. So fancy graphics cards, oh yeah, boy, they suck up the juice big time. Hard drives, nah. So air-cooled is very common in the server world, not water-cooled. You might think, well, why? Well, water-cooled is great, but it's not good for expandability. I can't say, oh, wait, let me swap out this, or let me add to one of these guys. It's a pain. So almost all servers are just air-cooled. And they have multiple fans, like row of 5 fans running. And they're all monitored. If any one of the fans failed, it'll let you know. So lots and lots of redundancy. And so therefore it is noisy in a server room. Very noisy. In fact, some rooms would even require OSHA hearing protection to be able to go into the room. Yeah. So lots of redundant fans. And obviously all the components are being measured for temperature. We're going to talk about performance monitoring here in just a second. But so if anything starts getting hot, it'll let you know. And then power supplies, we talked about that. We're probably going to, 240 volt, probably 30 amp or more. And then lots of them. I don't know of any server you can buy that has one power supply. They just come with two. It's for redundancy. Okay, so physical ports. Oddly enough, this is one of the crazy places where you could probably find an old style 15-pin VGA adapter, a connector. Yeah, because in the server world, it doesn't really matter. We're talking about some cheap stuff. So if display port versus HDMI, I will confess they probably do have HDMI, but you can still find a VGA port on a server. Yeah, on the front panel of a server. Those things still exist. USB ports, I would plug them with a wad of paper and a piece of Scotch tape. That's what I would do. So why do I do that? Well, I've had a thing where I was talking to a salesman in the server room, and he reached into his pocket, pulled out a USB drive, and was going to plug it in. I slapped it out of his hand and told him, "Don't you dare touch my machines." That happens. Okay. Understanding performance monitoring. So now we're kind of done with hardware. Now we're talking about software. So wouldn't it be kind of cool if you were psychic and could tell in advance when something was going to fail? When issues are really, really small, you could go, I better keep track of that, make sure it doesn't become a big problem. Oh, you don't want to wait until the problem gets hard, it gets really bad, right? You want to be able to see it in advance. That's what monitoring is all about. Monitoring isn't failure monitoring, it's performance monitoring. And if you have a baseline, so for example, it used to be that I could do, let's talk about database server. I could do 2,000 transactions per second when I first built this thing. But now I'm down to 1,000 transactions per second because of the use. And so I could probably plot this over time, right? Here's what it was before. And so I could say, okay, in 6 months, we're going to need another server. That's how you get money when you go up to talk to the bigwigs about, hey, I need a new server. You can't just wave your hand and say, yeah, we're getting kind of slow. But if you show them numbers, show them a chart saying, here's the performance over time, and we're going to hit 0 here. So we need to do something. Okay. So the whole story of chasing the bottleneck, a lot of people spend an awful lot of time finding out which component in a server is really causing the most performance issue. Is it the RAM? Is it the CPU? Is it network? Is it storage? It's almost always storage, by the way. The storage just cannot keep up with the modern stuff. But you can lessen the impact by swapping these guys out, but you're never going to make it go away. Something's going to be a bottleneck. I mean, if you fix this one, well, that means just now that something else is now the bottleneck. If you fix that one, that means something else is going to be the bottleneck. So it's a foolhardy chase on chasing down everything. I mean, clearly you want to know what the bottleneck is, but don't go crazy. And of course, there's an awful lot of metrics that you can use, and it'll suggest which things you want to monitor and which things you do not. So performance monitoring as a whole. So here's what you're supposed to be doing. You're supposed to be documenting the existing hardware, software, and all the configuration, and then gather some data for the baseline before you make any changes or when the server is brand new. For example, when I install a brand new SQL server, I do some performance monitoring on it, and I store that away as my baseline that I can use to compare it with every 6 months or so. So you make some changes. You upgrade the server hardware or software or something, and you compare it against the baseline to see if what you did helped. I mean, it'd be kind of silly to say, I want to add more RAM, and then you go back and go, well, that made no impact whatsoever. I'm chasing the wrong bottleneck. So you can't just blindly start adding stuff. You're supposed to be monitoring this thing to tell you what stuff you need, right? Don't want to add stuff that has no impact. Okay, gather the data and compare it, and then identify what the bottlenecks are, and then take steps to fine-tune that performance, either software tweaking or perhaps even hardware tweaking. So server baselines, page 283. The original out-of-the-box performance would probably be the first day you fired up the server, check out some bottlenecks, check out some server stuff. And so find out what the normal everyday were, so out of the box, you have nobody using it. So that's probably super base. I don't know what you would call it. And then a normal work day, early on in the life of the system, don't pick a weekend or something like that. Pick a Monday or a Tuesday, and then record what the normal baseline operations are, and then that's the one you compare a month later or 6 months later. Not the out of the box guy. So what are some of the things you would normally do? Well, I would do processor utilization. How much is it, like 80%? That would be super duper. RAM utilization, it's probably going to be around 80%. Read and write disk operations, yeah, that's probably going to always be the bottleneck, almost always. And then network utilization. So we're going to do one. On page 285, I'm going to do a thing here. I'm going to go ahead and just type in, I'm going to type in perfmon. See if you can find perfmon. Yeah, there it is, perfmon. Cool. Okay, so I don't really have anything set up yet. So the machine is just basically talking about, here's the typical kind of things. So here we are. I have 32 gig of RAM, available memory. Each processor gets 2 gig, and I currently have no faults. By the way, a cache fault, that sounds like a bad thing. That's not what they're talking about. What they're talking about is every time you ask for something and it goes to the cache, and the cache is in the item you want is not in the cache, it's considered a cache fault. That does not mean bad. That just means I have to go get the thing from the disk. That's all. It's just not. It should have been, is it in the cache? But they didn't call it that. They call it a cache fault. And so I'm not actually doing anything now on my my 1 gig, a little bit. And then disk, I'm not currently doing anything. And wow. Okay. So all the disks and all the processor interrupt time, processing time. So I'm using right now I'm using about 14% of my my CPU, because I'm doing jack shit right now other than talking to you guys. My monitor isn't doing anything at all. Okay, so this, it wakes up with the processor time. I kind of like that, and you can add an awful lot of stuff to this thing. So that's kind of the cool thing. So there's another one called a resource monitor. This is the performance monitor. There's one called resource monitor. So I'm going to go down to here and we'll talk resmon. So resmon is like it's basically, it's kind of sort of the same thing. I mean, I do like the cool little graphics showing, how much CPU, how much disk, how much network, how much memory. I like those guys. And of course, you expand these guys out and get more information about what's going on the disk, the network, memory. It's the same information, except for this is basically just talking about what you can see. It's not recording it's not recording anything, so you can use it as a baseline. But I would, if something was going on, I'd say, hey, my machine's really slow. I'd probably go here first to see, it's a disk issue or it's a network issue. It's almost always going to be disk, by the way. What's slowing me down? It's almost always going to be disk. Okay, so what's the difference between the two? Well, this one basically has the top 4. It has the CPU and memory and disk and network. The top 4 guys, and they have pre-selected things that they're recording. I don't really have much of a choice of going in and add something. But the others, I could go in and say, hey, I want to know, this one specific thing, so I could add a particular monitor on that. And there's no real reporting capability. It's basically just looking at it, going, yeah, that's cool. Task Manager. We've done Task Manager before, I believe. So I'm just going to type Task Manager. And so Task Manager basically is all the things that happen. You've seen all this stuff before, right? And so in a server world, this is the apps here are the ones that I am running, okay, me running, and here's all the background processes. Now I did not start this guy up in the admin mode, so I can only see my processes, not everyone else's processes, which is okay. I mean, you've seen this stuff before. Hey, we're coming up on the 15-minute mark.